What we're going to be doing today is using the completing the square technique to convert our quadratics from standard form into vertex form. Remember, in standard form, we have y equals ax squared plus bx plus c, and your vertex form was y equals a times x minus h squared plus k. And we said that they both have the same a value. So one of the ways that we did this was with standard form, we did negative b over 2a, and then substituted that value into our function for the y-coordinate of the vertex. And then, that negative b over 2a gave us the x-coordinate. The substitution gave us the y-coordinate. So then we took a from standard form and then the h and k and made vertex form. So that can be a little bit time consuming. So we can do the completing the square technique because remember, when we complete the square, we create a perfect square trinomial, a number plus or minus, x plus or minus a number, that quantity in parentheses squared. Well, that would be your h value. And then whatever number we added to the outside would be your k. So write the quadratic function in vertex form by completing the square, then identify the vertex. So remember, when we complete the square, we take our b value and divide it by 2 squared. Well, negative 10 divided by 2 is negative 5. Negative 5 squared is positive 25. Now, when we completed the square, so let's do y equals, when we completed the square yesterday, we would take that 25 and add it to both sides. And you see, well, there's no both sides here. Everything is just on one side of the equation. So what we're actually going to do is we're going to add 25, but we're also going to subtract 25. Because this right here is really equal to 0. So I didn't change anything in the equation. And then remember, we had this plus 22 right here. All right, so now I'm going to factor this. And remember, that's going to factor to x minus 5 squared. Because of this negative 5 we got up here, it's going to be minus 5 down here. And then we can combine our like terms here. This negative 25 plus 22 is negative 3. So our quadratic is y equals x minus 5 squared minus 3, making our vertex positive 5 comma negative 3. So with this next one over here, okay, we're going to do our b value, 18 over 2 squared, which is 9 squared, which is 81. So I'm going to add and subtract 81 from the right side. So y equals x squared plus 18x plus 81, and then also minus 81 plus 95. This factors into x plus 9 squared, and then negative 81 plus 95, that's going to be positive 14. So then our vertex is negative 9 comma positive 14. All right, then this one, our b value is negative 4, so negative 4 divided by 2 squared is negative 2 squared, which is positive 4. So x squared minus 4x plus 4 minus 4, and then we have that minus 1. So this will factor into x minus 2 squared, and then our combining like terms here, negative 4 minus 1 gives us negative 5. So that makes our vertex positive 2 comma negative 5. So example 3 here looks different because our a value isn't 1. So what we're going to do with this is we're going to group these together And we're going to factor out the 5 from just those two things. Like, we put those in parentheses and we leave that 7 alone. Well, now when we complete the square, what we're going to have to do is account for that 5. There we go. So we're still going to take our b value, which is 2. So 2 over 2 squared, which is 1 squared, which is 1. All right, so we have to take that 1 and we have to add it and subtract it. So y equals 5, x squared plus 2x plus 1. Now, since I'm adding that 1 inside the parenthesis, what I am really adding to the problem is 1 times 5, because that 5 was factored out. So I really added 5 to this side. So when I have to go to this part here and subtract my number, I'm actually subtracting 5 and not 1. I didn't subtract 1 even though I'm adding 1 right here, and it's because of this 5 that I factored out in front. So then I get y equals 5, x plus 1 squared plus 2. So then my vertex is -1, +2. So you're not going to encounter many this year that have an a value that's not 1, because you may just want to use a different method in that case for completing the square, because remembering to multiply that by that factored number can be confusing. All right, example 4, we have the height, y, and feet of a ball that was thrown up in the air from the roof of the building after t seconds is given by that function. Rewrite the function in vertex form, find the maximum height of the ball. So we're going to do this by completing the square. Now, if the problem was just asking you to find the max height of the ball, you could do -b over 2a and get the x value and then plug that back in. But because we're asked to write the function in vertex form, it might be easier to complete the square first. Okay, so now I'm going to factor out a -16 so that my t value is 1, or my a value is 1, then the number in front of t squared is 1. So then my b value here is -4, so -4 squared divided by 2 squared. That gives us -2 squared, or +4. -2 squared, which is +4. So I'm going to add 4 inside this parenthesis, but then when I subtract 4, again, I'm not going to subtract 4, I'm going to subtract 4 times -16, which is -64. And since I'm subtracting -64, give me minus 64, or adding. Factor that to t minus 2 squared, and then 50 plus 64 is 114. So my max height is going to be 114. Do they tell us? Yep, feet. So this is just asking what is the max height of the ball. So you could do the same thing we did here, or you can do the -b over 2a. -96 over 2 times -16. That's 96 over, -96 over -32, which gives you 3. And then you can substitute 3 in for t. And this will give you the maximum height. All right, so we're going to type this in the calculator. -16 times 3 squared plus 96 times 3 plus 3, and we get 147 feet. So that didn't take that long, doing it the negative b over 2a. And in my personal opinion, and this is again just my preference, if I'm asked to find the vertex or the minimum or maximum, and our a value is not 1, I think it's probably quicker to do the negative b over 2a that we just did for this problem and then substitute that back in. But if our a value is 1, then completing the square is not a bad method to get the vertex form and then calculate the vertex from that. All right, so thanks for watching. Make sure to like the video and subscribe.